Hello, welcome to my YouTube channel PowerBud. Today I'm going to explain about PCB cross-section. So this is the cross-sectional view of a printed circuit board. Here you can see the multiple layers arrangement. So some are like the conductive material, some are dielectric, and you can see some holes, plated, unplated holes in between, and in between you can see some copper layers. So this you can see here. This is not a conductive material. This is non-conductive core material. This may be any kind of glass fiber like FR4, and we have a pre-pack material. This is also not a conductive material, and you can see here we have some plated through holes and some unplated holes, and there are some like top solder mask, bottom solder mask. This kind of structure you can see in a multi-layer PCB cross section. So I will just explain what is the function for all these sections and what is the use. So for a multi-layer PCB, it is like nothing but multiple layers of conductive materials and dielectrics stacked together. Then you will get a multi-layer printed circuit board. And these layers include, as I mentioned, you will be having a core material and a pre-pack material or insulative material, and you have the copper layers. This shaded material is nothing but the copper material or the conductive materials. So why you are stacking up together means you may need to introduce isolation between the copper materials. You may need to increase the strength of the printed circuit board. Then you have to introduce all these layers. So mainly it is to isolate the different type of conductive materials and also to improve the strength of the board. So sometimes, for example, this board size may vary from 0.8 mm to 1.6 or 2.65. Sometimes you may need to prepare a 3.2 mm printed circuit board. So this is based on different type of application and the number of layers of the printed circuit board, like how many layers you want to stack up, whether you need a 4 layer PCB, 6 layer PCB, 8 layer PCB, like that. These all factors will like involve it will be having a control over this layer arrangement. So I'll just explain what is all these main layers. So core is the main rigid base of the printed circuit board. So it will be having more thickness compared to the pre-pack material, and all are FR4 or any kind of other glass fibers. But this is the main layer of the PCB, the core material. So do not swap the core material with the pre-pack material because it will be having some FR4 dielectric strength or dielectric parameter variation. So this is the core layer and the pre-pack layer. Like this is the core layer, and pre-pack layer is the insulating material between the layers. So if you are adding a 4 layer PCB, for between each layer make sure you have an either a pre-pack layer or a core layer. Both are insulative materials. So the better the standard method is to follow by including the pre-pack material. And you will be having the copper layers. So the copper layers is nothing but the conductive materials. So there this copper layer also will be having a slight variation of thickness. So internal layers and external layers will be having a difference in thickness. Why? Because in external layer you will be having an additional coating. For example, a tin plating or a gold plating will be there. So this will also affect the thickness of this copper layer. These things you have to consider when you are designing a multi-layer PCB which will be having different current or different voltage requirements. And this is the layer, the solder mask layer. So solder mask layer generally you will be applying on top and bottom of the PCB. So solder mask is also not a conductive layer, it's an insulative layer. So this solder mask layer will help to protect the copper on top of the PCB and bottom of the PCB. So mainly it will help you to prevent the short circuit or any damage, scratch on top of the PCB. And additional benefit is applying solder mask is nothing but the you can avoid the corrosion of this material. So we will be using the copper layer. So copper layer will be undergoing this oxidation problem. So these and all will be you can avoid by including the solder mask. So generally everybody will be following to use the solder mask material. In olden technology, only people used to do not included the solder mask. So you can see this. The first thing will be visible once you see a printed circuit board is the solder mask. It may be in different color, white, green, and purple. So it depends on the solder mask color they are using. Then the build-up layers. So here you can see the additional layer. So you can see here this is a top layer copper. Inside you can see two additional layers, right? And this is the bottom layer. So these inside layers, inside conductive copper layers are called the build-up layers. So there are two types. This is the top build-up layers and bottom build-up layers. These are the top build-up layers and these are the bottom build-up layers. So what is the advantage? So why you are using this internal layers? So mainly, for example, you have to design a printed circuit for a mobile phone. So in that case, you have to include many components on top of the PCB. You have to do multiple routing, right? Many routing on the PCB. But there is a constraint, space constraint. So this addition of this build-up layers will help you to reduce the space, mainly the size of this PCB it will reduce so that this space required to fit the PCB is also will reduce, and it will support the compact design, of course. And this will also help to reduce the board length width. Okay. The next one is the vias. So here you can see many vias. So one is this plated through hole via, and you have some plasma microvia, the paste filled vias. These are the blind vias, some buried vias, and some plated through hole back drilled and unplated holes. Here also you can see some blind via. So what are these via? So vias are the small holes that connect different PCB layers. So like this here you saw, right? One layer is here and another layer is here. All are connected to maybe a 5-volt supply. But how you will connect? So you need some kind of a bridge between all these layers, which will connect all these layers together. So here this copper plated hole will help you to connect all these four layers to a single net. So 5 volt may be coming from this side, so 5 volt is entering. So this 5 volt directly going to the top layer. Now you want to tap the same 5 volt to the internal layers, then this 5 volt will be appearing to the internal layers through this wire. So these vias are like kind of a conductive path to the uh, internal copper layers. And this will help you to electrically connect. So here you can see this is plated through hole, this is unplated through hole. So generally in the beginning of this PCB circuit design, people will miss to mention this is a plated through hole. So when you place a wire, make sure you have the it is a plated through hole wire. Otherwise, if you are keeping, like for example, unplated through hole, it will not connect this internal layers. You can see this is a top layer, this is an internal layer. So this unplated through hole will not help you to connect between the internal layers, but a plated through hole will help you to connect between the internal layers. So both we need sometimes. For example, this unplated through hole, you may need to drill the PCB for fixing the mounting positions. For example, this it will be acting as the mounting holes along the corner of the PCB, or sometimes it will act as a supporting hole for some of type of connectors. So you need this kind of holes also, but the purpose of unplated hole is not for the electrical conduction. This is for mainly for the mechanical support. Okay. Uh, so uh, so vias are very much essential for this multi-layer routing. Otherwise, you cannot establish a connection between top to bottom or top to the internal layers. And there are many different vias, so this you need to know. And also you need to study how to you need to learn how to implement these different types of vias in a printed circuit board. Each have different kind of purpose. For example, this complete through hole wire, so it will be connecting from top to bottom, and it will be connecting between internal layers. So when you define this plated through hole wire, you will define top layer, inner layers and bottom layers. So once you place this, it will automatically connect to top layer and inner layer, bottom layer if the electrical nets are same. For example, if this is 5 volt net and this is a 0 volt net, then it will not connect between these two layer, because there will be some clearance or clearance defined. We will be defining some clearance in the tool, so that because of that clearance it will not automatically connect to the internal layer, because it is of different net. But if it is of same net like this, it will establish a connection. So this is the through hole wire, this is a standard wire. So you can survive, like you can create a printed circuit board if you know only this wire. And the second is the blind wire. As the name suggests, if you look from one side, you cannot see the other side of the PCB. That is the blind wire. So mostly the blind wires will be using to connect the top layer to any of the inner layer, not from top layer to the bottom layer. So here you can see here the bottom layer is connected to inner layer, not there is no hole throughout the PCB. It's like a small kind of a slot, but it will be connecting from top to the second layer. You can see this is the connection. This is the blind wire. So why you need blind wire means may not be having enough space for a through hole wire, because sometimes this through hole wire may be over designed. For example, I only wanted to connect between these bottom two layers, then why I need to drill the complete PCB? So in that case you can use the blind wire. This blind wire will be having more cost compared to this plated through hole wire. So when you are developing a blind wire, the cost addition will be more. Then second one is the buried wire. As the name suggests, it will be buried inside the PCB. Like you can say this is a buried wire. So from top or bottom you cannot see. Just by seeing the PCB you cannot assume that there is no wire. There is a wire, but it is buried inside the PCB, and this is only to connect between the internal layers. You can see it is not a complete through hole. It is just connecting second, third, fourth and fifth layers only. So this is the buried wire. As the name suggests, you can easily distinguish the blind wire and buried wire. Blind wire means one side you can see, other side you cannot see. Buried wire you cannot even see the wire, but it is like a buried inside the PCB. Like here I mentioned, hidden inside the PCB. Then next one is the microwire. So microwire is like this. It can be like uh, a plasma or laser wire. So microwires will be having very very less diameter. So this you can see here a paste filled microwire. This one also is a microwire. So you can see compared to this diameter, this is very less. So precision has to be high for this kind of wire. If you have a very space constraint, then this kind of wire will be using, and also you only need to connect between the layers means these kind of wires will be using. Here, major consideration is the space constraint and high precision. So the diameter will be very less. So you cannot use this standard methodology which you may be using for developing this kind of wire. So generic methods using is this plasma method and the laser method. So plasma is like a gas. Uh, they will be using a gas method and cutting this kind of a microvia. Otherwise, using laser it will be cutting. Okay, and next one is the filled microvia. So filled microvia is nothing but it will be having you can fill with either conductive material or you can fill with the insulative material. So based on the requirement, so if you just need for the heat dissipation, you can fill it with the heat dissipative helping material, or you can fill with the conductive material. Then back drilled wire. So this is the back drilled wire. This is also like kind of a wire. From one side you can see other side, but it is not completely plated. So few area only it is plated. The other area it will be non-conductive. Like you can see, first they will completely drill here. They will only plate between these layers. They will not plate here. These are the back drilled wire. Like here mentioned, unused portion will be removed, and this is mainly for this high speed signal performance. So you only need to, for this area means they will only apply here. Then unplated hole. This is the unplated hole. Unplated hole you can consider mainly for this mechanical support, like mounting holes or any kind of fixture holes for the connectors, or if you just pass from uh, s- wire from top to the bottom. So these kind of things you can use this unplated hole. Here I mentioned it is as mainly for the mechanical support. Yes. So that's all about this PCB cross section. Thank you for watching the video. Have a nice day. See you. Bye.